Welcome to 6-Minute Statistics. In this video, I'm going to define for you the most common types of events in probability. We're going to revisit the 6-Minute Statistics Casino to see how we define these terms. And with a little luck and maybe some good editing, we're going to do it all in 6 minutes. Come on!
Give me 6 minutes and I'll teach you something new. Now, let's get to work.
Mark here from 6-Minute Statistics, and I want to continue our conversation about the wonderful world of probability. In my first probability video, I talked about some basic probability terms like experiment, sample point, sample space, and event. This video adds to that discussion as I look at a variety of the types of events that we can see. Please make sure you've watched that video first before proceeding here. The same warning I made in that video about the danger of gambling applies to the roulette and card examples that I use in this video. Please gamble responsibly. All right, let's start with a recap of the game of roulette. The typical American roulette wheel has the numbers 1 through 36 that are either red or black, and then 2 additional green spaces labeled as 0 or 00. There are a total of 38 possible outcomes for the ball to land. The 0 and the 00 spaces don't count as either odd or even, and are the main reason the house has a betting edge. In my first probability video, I defined sample events to be the most basic types of outcomes of an experiment. For instance, if we observe the value 15 on the roulette wheel, that is as simple as it gets. That's a good example of a sample point. Events, on the other hand, tend to be a little bit more complicated, as they are combinations of outcomes. I want to cover the most common types of events in this video. Let's start with an event called a union. I like to think of the union as the OR probability. A good example of a union would be the outcome of observing an even number. Getting an even number would include the values 2 or 4 or 6 or 8 or 10 all the way up to the value 36. It's a combination of a lot of different sample points. Likewise, getting a number in the first third would be an OR probability. It'd be the outcome 1 or 2 or 3 or 4 all the way up through the value 12. Both of these are giant OR probabilities that we call unions. The next type of event is called an intersection. Whereas the union is the OR event, the intersection is the AND event. We might be interested in observing an even number and a number in the first third. While even number and first third are both OR events, we now want to put them together with the AND intersection. So which sample points are both even numbers and in the first third? Just the sample points 2, 4, 6, 8, and 12. The Venn diagram that I talked about in the first video can be helpful in visualizing these probabilities. Notice how OR probabilities include all sample points in either of the two events, but the AND probabilities only include the sample points that are included in both. Even number or first third would include 24 of the 38 sample points, while even number and first third only include 6 of the 38 sample points. The next step is to define the complement of an event. I would call this the NOT event. The complement of the first third is all the outcomes that are not in the first third. There are 26 of them. The 0 and the 00 would be included in the complement here because, like with everything else, they're not considered in any of the thirds. Try thinking about the complement of the OR and the AND events we've already discussed. The complement would be the NOT event, or the opposite of what we found earlier. Mutually exclusive events are events that cannot happen at the same time. First third and second third are mutually exclusive events. We cannot observe a sample point, or an outcome on the roulette wheel, that's both in the first third and in the second third at the same time. Same with even and odd. An outcome is either even or odd, or maybe neither if it's a 0 or 00, but it cannot be both. Since there's no intersection between these two events, in other words, they cannot happen at the same time, we say they are mutually exclusive. One more thought on the mutually exclusive idea. If two outcomes can happen at the same time, like even number and first third, 2, 4, 6, 8, 10, and 12 are both, we say that the events are not mutually exclusive. All right, I have one last type of event for you. Independent events. Two events are said to be independent if observing one of the events doesn't change the probability of observing the other event. For this example, I'm going to switch to the playing cards I discussed in the first probability video. You may recall that a standard 52 card deck has 13 cards in each of the 4 suits: clubs, spades, diamonds, and hearts. I'm going to define 2 events here. A is the first card dealt is a heart, and event B is the second card dealt is a heart. Now, imagine, if you will, we shuffle the deck and randomly choose a card. 13 of the 52 cards can result in a heart, so we know that the probability of A, the first card is a heart, is 13 out of 52. But what about the second card? If I take that first card, put it back in the deck, reshuffle, and turn over the second card now, it also has a probability of 13 out of 52. The first card didn't affect the second card at all because I reshuffled. We would say in that case, events A and B are independent. Knowing that A occurred doesn't change the probability of B. Now, what if I don't replace the card? What if I just leave it facing up? The probability that the second card is a heart, the probability of B, depends on whether or not A has occurred. That's the definition of dependent events. This leads us into the conversation of conditional probability, but I'm going to save that for another video. For now, let's see if you can get a firm grasp of unions, intersections, and complementary events. Also get a pretty good grasp on mutually exclusive and independent events. So what's next? Well, for me, I'm going to go back to script writing for my next video, and for you, you have to practice with these types of events. So I guess for both of us, it's time we get to work. See you next time.